I am going to preface this and quite possibly, oh no, that's not for a while. Mutually exclusive and inclusive events are not really my favorite sort of thing.
Say it 5 times.
Mutually exclusive slash inclusive. We probably need to define those words before this makes any sense. The word exclusive. Anybody? Those of you in the dating world, which I know some of you are, if you're dating somebody exclusively, I won't ask for specific names out there. What does that mean?
How about exclusive or like limited edition? As in like this is an exclusive car. Only buy me.
Well,
No,
you're doing it collectively as a group there. Exclusive means kind of singularly, whereas in math, anyway, well, I guess we should define it as this. Exclusively means that things cannot happen at the same time. Cannot happen at the same time. Where, when we talk about inclusive events, inclusive means that they can happen at the same time. And we were looking at this in terms of probabilities. And we were looking at this in the terms of the word and, when the probability uses the word and. Let me give you an example because I don't know if it'll make any sense until that happens here. So for example, this. On a dice, the probability of rolling a 6 and 11. That means if you roll your dice and you roll them out there, what is the probability that you get a 6 and an 11? Okay. Those can't. There's when you roll a dice, when you roll 2 dice, there's no way that these 6s can't be 11s and 11s can't be 6s. Let me give you another one. How about this one? The probability, see if you can see the difference of this. Probability, this might clear it up, or it might make it more confusing, of rolling an 8, rolling an 8, and wait, at least one odd number. So this is going to get a little confusing. Do you happen to have the little chart that I gave you that has the dice thing on it?
We got a chart.
Remember I gave you the chart, we could roll 2 dice and you could tell the combinations, or 1, a 1, and a 1, a 1, and a 2. Nobody has that. What?
You never gave that.
Not this year, but last year.
I remember giving it
Oh,
to
You're
us.
supposed to keep such things. Here. So, let's do this. Write this on your paper. And I am going to punt. So here we go. Write this on your paper. When you roll the first dice, you can roll a 1, a 2, a 3, a 4, a 5 or a 6, right? I'm trying to make it look like a dice. It's probably not. Same thing for the second dice that you roll. You can roll a 1, you can roll a 2, you can roll a 3, you can roll a 4, you can roll a 5, and I should have made this a little bigger, you can roll a 6. Here's the most important part right here. What do you get when those things, so if you roll in 2 dice, you can get a 1 and a 1, which gives you a 2. You get a 1 and a 2, that gives you a 3, a 1 and a 3, that gives you a 4, a 1 and a 4, that gives you 5, 6, 7, right? You get a 2 and a 1 and get a 3, 4, 5, 6, 7. Trust me, just fill these in, you'll see the pattern going there, you're gonna get to spend forever on this. Right? Told you this is not my 14. Or a 5 to either. Thicker? Do you have that so I can forge ahead?
Yeah.
Oh, perfect. Thank you. Here's what. This could work out well for you.
That's it.
Oh, yeah.
Try tapping the cross.
Maybe you should like.
Maybe I should just quit for the day.
Oh, now it works.
Whoa, June. I'm entering today. Alright, I'm going back to this page here. This is what is meant by mutually exclusive and inclusive events. I am going to put my little cube up here so you can see it there.
That's beautiful.
And then I hope I can shrink it down so I can see both of these things here. Okay, here's the deal. 6 is, when you roll a 6 and 11, they don't overlap. You can't get, when you roll a dice, you cannot get both a 6 and an 11. You either get a 6 or an 11, or one of the combinations of that. You can't do them both at the same time. Over here, this says the probability of rolling an 8 and at least 1 odd dice. So you look at the combinations, these are all the ways you can get 8. You can get a 6 and a 2, a 5 and a 3, and a 4 and a 4. Those could happen at the same time. You can roll an 8 and get an odd number on a dice. Okay, those can happen simultaneously. That is inclusive. Exclusive means it can't happen together. Everything you've done so far in probability has been exclusive. You've never done any inclusive things that could happen both at the same time. Okay? So here is the difference in the two. This one, if it is exclusive, probability equals, the probability of those things happening is the probability of the first thing happening. Make sure I do it. Probability of the first thing happening plus the probability of the second thing happening. You add the two probabilities together. This isn't multiplying, this is adding the two probabilities. Because you have two different things happening here. We're not asking for them to happen at the same time. So what is the probability of rolling a 6? How many 6s are there? 1, 2, 3, 4, 5 out of how many combinations? 36, right? I'm sure we did this before. If we count all these up, there's 36 of them. What's the probability of rolling, what was my other, an 11? How many 11s are there? Out of how many? 36. The probability of both of those, of doing those back to back, is what you get when you add those together. Your probability is 736. That's your probability. Okay? If there's an and in your probability, you add the probabilities together, as long as they're exclusive. If they are inclusive, you do the same thing. It's the probability of A plus the probability of B, but after that, you have to subtract the probability of the overlap of the A and the B. And I'll show you what that means right here. What is your probability of rolling an A? An 8. How many 8s were there? 1, 2, 3, 4, 5. It's 536. Okay. What is the probability of rolling at least one an odd number? Make sure I got this right here. Oh my gosh, what is it? Well, you have to look here. Look at all the different ways you can roll. So anything that has a 1 in it is an odd dice. So you gotta circle all these because this is when we got 1s. Correct? Circle all these because that's when you get 1s on the other dice. Circle all these because this is when you get 3s. Circle all these because that's when you get 5s on the dice. Circle all these because you get 5 on the other dice. Circle all these because you get 3 on the other dice. What is your probability? Well, how many? Let's count how many we don't get. 1, 2, 3, 4, 5, 6, 7, 8, 9. So take 9 away from 36. It's so 27 out of 36. Your probability of getting at least one odd dice is a lot. You add those together, you get 32 out of 36. But the deal is, you have to then subtract the times when they both happen at once. So you have to find times when you get an 8 and you have an odd dice. So you look in your little thing here. Here are my 8s. How many of these times do I have an odd dice? Here, because it was a 5, and here because the other one was a 5. So from that, you have to subtract the 2 times that they overlap. So when you take 32, 36 minus 2, 36, you get 30, 36, which reduces down to 15, 18, which reduces down to what? We said what? Is it 5 over 6? 5, 6. Is your probability of that happening together? Stritz, what do you think? You want to say here, look in your books. You can't, sometimes this stuff can't be done unless you actually sit down and do some examples, which I'll help you with. I am going to literally hold your hand through this. Not literally. That would be wait, what would it be, metaphorically?
Yeah.
Yeah, metaphor.
It's a metaphor. Look at page 446. I am going to walk you as much through this as I humanly possibly can. Letter A. Are you there? Letter A says, what is the probability of rolling either a sum of 2 or a sum of 10 using 2 number cubes? So you have to go back to our little chart. Is that inclusive or exclusive? Can you roll a dice, and when you look at those dice, will it either be a 2 or a 10, or will it only be one or the other? The sum. When you look at it, can you roll a dice and at the same time get both a 2 and a 9? I take 2 dice and I roll them and I look at them. Can it both be a 2 and a 9? No. So that is exclusive. It just means probability of A and probability of B put together. So what is the probability of getting a 2? Look at your little chart. How many ways could we get 2 when we roll 2 dice? How many 2s are there? 1 out of 36, right? There's only 1 2 there. How many different ways were there to get a, what was the other one? A 10. This was a probability of 2 and a probability of 10. How many different ways are there to get 10? 3. So you add those together because they're exclusive, they can't happen together. The probability is 1/9. 1 out of 9 times you should get either a 2 or a 10. How about number letter B? What is the probability of rolling at least one even number and a sum or a sum of 3? Probability of even or a sum of 3. Okay, can you get a sum of 3? When you roll a sum of 3, is there a possibility that the dice has one of the dice is an even number? Yes, so that is inclusive. Which means you have to add their probabilities together and then subtract how many times that happens together. How many even numbers was it? It's going to be the same as the odd numbers, by the way. What did we get when we did odd numbers? 27 out of 36. It'd be the same exact thing except with even numbers. How many different ways to roll a 3? 2. I'm going to add those together and then I have to subtract. How many different ways can they happen together? Let's go back to my little chart here. How many different ways can they happen together? 2, because there's no way to get a 3 without an even number, so you have to also subtract. You really have to end up subtracting the same thing you just added together, right? So 2736 plus 236 minus 236, you get 2736 again, which is what? 9. What is it?
3/4.
No, yeah, 3/4. Okay, here it comes. Stritzel, you'll like this one because it talks about music. You see letter C? A digital music player randomly selects a song from a group of 12 rock, 12 pop, 5 Elvis, and 3 alternative artists. What's the probability that the music player selects either a rock or alternative song? So the question you have to ask yourself, is it inclusive or inclusive? Can a song be both rock and alternative? I don't believe so. I think they're just
I think there's rock slash alternatives.
But so if the song cannot be both of those, then it is exclusive and you just add their probabilities together. They wanted the probability of what? Rock or alternative. They can't happen together. You can't have something that's called both rock and both alternative, so you just add the probabilities together. Which is what? What's the probability that it is rock? There's 12 out of how many total?
36.
Is it 36 again?
No. 32, yeah.
32. How many alternatives? 3. And it's still going to be 3 out of 32. So you add those together, you get 15, 30 seconds. Can I reduce that? I don't think so. Ready? Here comes the big one. Let's finish strong. If you can work with me here, there's a good chance we'll only have half the problem, not all of them. Angelina uses Bryson's data from example 3. Oh no. We didn't do example 3. No. Let's look for a problem in the book. Somebody find one that has 68 on it.
12. No, it's
21.
11.
Oh, wait, no.
12.
12.
12.
That's less than
That's
7.
problem 7. Less than 7. Somebody said 12. You yelled 12.
No, it's gotta be. We gotta do 12. Why is it got? Yours, mine says 7.
Mine says 7.
Let's do this one quick.
10 and 11.
There are 75 knives. How many forks?
50.
50 forks.
75.
75 spoons.
20
20 of the forks and 30 of the spoons have red handles. 20 forks are red handles. 30 spoons have red handles. If a piece of silverware is chosen at random, what is the probability it will be a fork or have a red handle? Probability of fork and probability of a red handle. So the question you have to ask yourself is, are those separate or are there forks that have red handles? There are forks, so that means it is inclusive. You're going to have to add probabilities together and subtract some probability. What is the probability that you're going to draw a fork? A fork, there are 50 out of, doing the math, 200. Right? 75, 75, and 50? Okay. How many things have, it's just a probability of fork and a red handle, right? 4 have a red handle. How many red handles are there?
1/4.
No. Well, is there? It's 50. 50 out of 200, right? Have red handles. 30 plus 20, they all have red handles. Okay, so there you go. 100 over 200. I'm going to keep it there in case we have to reduce. Now, though, you have to subtract how many have both, how many overlap, how many red-handled forks are there. Forks with red handle are 20 out of those 200. So when you take that away, you're left with 80 200s, which reduces down to 8 over 20, which reduces down to what? 4 over 10, which reduces down to 2/5. Did I get that right? Correct.
I believe so.
I looked at my book to just make sure. Go, please. Leave me alone. I didn't tell you it was easy.
This is another one that's not hard, it's just very confusing.
Or somebody with red hair.
Yeah.
Wait, you seriously didn't finish?
I did.
What are you doing?
1, 2, 3, 4.
Well, what exactly do you do? You finish at 6?
Let's correct.
No, it's.
We did 5 to 10. Is that actually right? And lesson what? Number 5. Delaney,
600 meters squared.
I have 600 meters cubed. It's
Sorry.
volume. It's volume. Number 6. Tyler, or
938.6 meters cubed.
find the volume of the tank. First express the volume in the tank in terms of pi, then approximate the volume to the nearest whole unit. What did you say you had?
938.6 meters cubed.
I have 490 pi for the first part. 490 pi meters cubed. And then to the nearest whole unit, if you multiply 3.14 times that 490, wow, I get either 1539 or 1540 meters cubed. How many people got that? Number 7. Here we go again. Another 3-unit multiplier to convert 1 cubic yard into cubic feet. Luke?
27 feet cubed.
Very good. 27 feet cubed. Number 8. Find A and B in the similar triangles to the right. Oh, I love that. These do not work out evenly at all. Jade, shoot. A is
7.
not 7. A is 32 over 5. And B is 25 over 4. You could change them to mixed numbers, I suppose. A would be 6 2/5, and B would be 6 1/4. How many people got that one? Oh, kids.
Wait, what is it? Decimals.
Oh, if you had decimals, then I guess it would be 6.4 and 6.25. Number 9. What is the area of that parallelogram, Grace? 80 centimeters squared. What type of parallelogram is that? Brooklyn? It is a rhombus. Number 10. What is that quadrilateral? Josh? It is a trapezoid. Its area, Mitch?
It is 71 inches squared.
Believe it or not, I have 72 inches squared. And its perimeter, Isabel?
36 inches.
36 inches. 36 inches. That's all we did, right? I'm sure we'll look at problem number 8 and quite possibly number 6. Kate?
Can you please explain number 8?
I'm sure we'll look at problem number 8 and problem number 6. Looking for anything you need to answer, read the time. Number 6. This is the way number 6 should go down. 6 said, suppose a municipal water tank has these dimensions, so the first thing you do would be to sketch that cylinder with its dimensions, 7 meters and 10 meters. And since it said, find the volume of the tank, Mitch, we wrote down the volume of the cylinder is what?
Volume is, wait, what?
The formula.
Oh, pi times radius times radius times height.
Beautiful. And then you fill in the blanks. It said leave it in terms of pi, so the pi doesn't get changed to 3.14 yet. Radius is 7 times radius, which is 7, times height, which is 10. 7 times 7 times 10 is 49 times 10. So that's where part A came from. The volume equals 490 pi's. Whatever that is, meters cubed. Tyler, where did you go wrong astray on that? Well, you didn't have the answer. What did you have for an answer?
930.6.
But even still, for the next part it said you actually take 490 and multiply it by pi, which is 3.14. You still end up with a lot bigger number than 900. 0, 36, 3, 16, 19, 0, 490, 0, 0, 0, 27, 2, 12, 14, 0, 6, 8, 6, 3, 5, 1539 I get. The book said you could have 1540, but one of those two. I'm not sure they came up with the 40, but. Okay, where'd you go wrong?
I got
Did you write the
7.
formula down?
Oh, for this?
Yes.
Yeah, I wrote it down. I wrote it in pi.
Did you get 495?
No, I meant I wrote it in pi. 1, 5, 3, 9.
Okay. And then number 8. You obviously drew the triangles right, 4, 5, and A. 4, 5, and A, and the second triangle was 8, 5, and B. 8, 5, and B. And you were supposed to find both A and B. A equals, B equals. Well, the first things first, children, I mean, you know, you could set this up in ratio box form. You got small triangle, big triangle. You've got hypotenuse, let's do that. Hypotenuse is the long side. And you have to use this side because this is the only other one that gives you both numbers for it. Okay, so you could call this, I don't know, the short side. Short side on the small triangle is 4. Short side on the big triangle is 5. Hypotenuse, we don't know, but the hypotenuse on the big one is 8. Correct? So how do you solve A over 4 equals 8 over 5? Yes, cross products. 5 times A equals 4 times 8, which is 32, and that's where the first answer came from, 32 over 5. Then you do the same thing for letter B. You know B on this side, and what is that? 5 over here. It's basically the same thing there. Another way to do it is you could have found the, what do we call this? Scale factor. 4 times what gives you 5? It's not easy, but you could do it. 4 times what equals 5? Divide by 4, divide by 4. Your scale factor from the small to the big is 5/4. So you multiply 5 times 5/4 is where 25/4 came from. And unfortunately, you'd have to take this and divide, or take this and divide it by 5/4 to come back the other way. We'll multiply that way, divide, come back. Come back. Cameron Colquitt, I feel we've learned something good today, haven't we? Your life has forever been changed to the good. I like that. Perfect. Take out a blank. Well, take out your notes under inequalities, please.